just a few minutes to join us, so hang on tight and we'll get started soon, okay? Just double check. Everybody can see the screen? Chris? All right, we're going to go ahead and get started. I'd like to thank everyone who is joining us today. Welcome to today's 6th Kubernetes birthday event with the virtual CNCF meetups. I'm Archie, organizer of Eastern Canada CNCF meetups. I'm CNCF ambassador and also working at Google as a hybrid cloud specialist. And today, it's our next virtual event, and this event is going over 5 cities: Montreal, Toronto, Ottawa, Kitchener-Waterloo, and Quebec City. So we have attendees from all of the cities and perhaps from other cities in Canada, as we also started, events in LinkedIn. So potentially there are more people who is joining us. And first of all, I want to say thank you to our team of organizers. So it's not only me and Julia now, it's a group of nice people from different companies who are helping us to craft these events, find speakers, help with the content and all this good stuff. So this event would not be possible without our team. So I hope you can meet all of them in future when things are going to get back to normal and we can start having, real events on site. But for now, it's a virtual event, so we just want to, mention them here. And of course, we want to say thank you to our sponsors. Without them, we would probably not be able to organize such great events. So you can see the sponsors here. If you want to become a sponsor, let us know. We're always going to be happy to have you over. We give our sponsors a chance to present at our talks and, just to get some visibility and help us spread the community. So we're going to go forward and have some meetup announcements. First of all, we have started our Cloud Native, Canadian Cloud Native Twitter account. So if you guys want to follow us on the latest updates, please join us. We also have now a LinkedIn group where you can join and, see the updates or maybe share some knowledge or ask any questions. So we're just trying with this new group and see how it goes. If you want to join, let us know. We can add you, as an invite, or you just can search it in LinkedIn. If you want to present at our talks, at our events, we have actually a few options right now. So we have Cloud Native Stories event. So this is mostly delivered by, community. So everybody who has their own story around Cloud Native. Like we have Steve today from Mettle. He will be speaking about Mettle's GitOps journey. So you can also present about your own company, and it's a very easy way to start presenting. It's 10 to 15 minutes usually, so you can quickly go over how things are working in your company and what a success you achieved with Cloud Natives and whatnot. So please submit your talks and you will be one of the speakers. Another event we are organizing is a virtual tech talk. So this is more over like a 40-minute technical talk with demos. Again, anybody can submit to that. We're having ambassadors speaking, CNCF project maintainers, community members, and our sponsors, and any company who want to submit. We're all looking into the CFPs and we accepting them if they're great. We also have our Slack channel. So this is the place where we can interact and, share updates. We have, many channels right now that we're trying to keep active as much as possible. So if you want to join the Slack channel, please, scan the QR code. We also have some CNCF updates. As an ambassador, I get happy, to share some of the news with the community. So one of the news that are perhaps, would be great for some, and some people were not so excited. Our CNCF meetups kind of scheduled to be migrated to the new platform, which is community.cncf.io. We're going to be moving out from meetup.com this year. So there's no action from your side. All your accounts will be migrated to the new platform. And you will soon get an email with that. And we're still going to be using meetup.com this year, but most probably in next year, there will be no more meetup.com for cloud native meetups. We'll see how it's going to go. We were going to be looking for your feedback. The goal is that you can find all the cloud native events around the world through this platform, similar to meetup.com. And you'll get notification the same way as you're getting from meetup.com. So we're not really worried about existing users. We're mostly worried about, new people who are going to be joining us, new community members. So for that, we're trying to, starting to use more LinkedIn and Slack and Twitter accounts to promote our events, so we can have consistency growth in our community. Regarding the KubeCon North America 2020, we were supposed to be going to Boston this year with everybody. The plan was to have a bus and get everybody from Montreal, Toronto, and Ottawa and Quebec City together, having some kind of a booze cruise. But unfortunately, with the COVID situation, we can't really go forward. And KubeCon North America is moving to become a virtual event. So the rest things are going to be the same. You can submit your CFP, you can, it's going to be just everything virtual, unfortunately. And, this is a new reality for us. And then for KubeCon Europe, which is going to happen pretty much next week, you can still, access, register to the event. You can get full event pass for $75, and you'll be able to access all the talks. There will be also workshops. If you not planning to attend it live, but you want to hear the keynotes, you still have, I think, few days to register for the free pass, and you can hear the keynote, live. So just, go ahead right now and make sure you're registered. So, at least you're not gonna miss the keynotes part. And then, the talks potentially you can either get later, or, if you can have a chance to attend the full event, it will help the community as well. And the money also, going towards help support for the COVID stuff. We're also trying to be active locally here, and we have similar event to KubeCon, but like locally. So there's something called Kubernetes Community Days. Toronto, Montreal, and Quebec and Ottawa are planning to organize. Due to COVID, everything is kind of postponed, but Quebec might be going still with the online version. So we'll be posting more information shortly. So most probably 2020, there will be no Kubernetes Community Days in person, because the situation with COVID is still not as great. So this is what's the story about that. So finally, I'm trying to move fast as possible, because we have a lot of talks today, interesting technical talks, and we have also kind of a journey stories from the cloud native. So we have today Chris Carty, who is going to be talking about managing multi-cluster and multi-tenant Kubernetes with GitOps and Flux. So he will cover more about Flux, which is, we actually never talked about Flux yet. We talked about Argo CD, and we have a lot of users who is using Argo in our community, but like Flux is the first time. And we also happy to invite Steve Waite from London at Mettle. He was one of our first speakers actually in our meetups back in days, maybe 5 years ago. He was one of our first speakers at our Cloud Native meetups. So we're happy to bring Steve again from London, and he will be sharing his company's journey with GitOps. And I think they're also using Flux. So, you'll get like a the theoretical part and more like real case scenarios, how people are using GitOps in companies. And we're also super excited to have Owen today from Grafana Labs. And a lot of people were super interested to hear about Grafana Loki. This is another exciting project, which is not cloud native at the moment, but it's truly cloud native in my opinion, even though it's not CNCF project. It's very interesting and growing community. So we have Owen that is going to present and hopefully do some demos as well around Grafana Loki. And at the end, we're going to try to make a small trivia with some prizes. So you can win a Kubernetes hoodie. So if you stick around all the way till the end of the event, which is going to be around 1.5 hours, we have a trivia where you can win some prizes. So we're going to ask some Kubernetes questions, some, like around cloud native. So if you feel that you know stuff, you can obviously try and win something. So stay with us. Yeah, and with that, I will be trying to get ready to hand over my microphone to Chris. A few housekeeping items before we get started. During the online meetup, you are not able to ask an attendee. You have a Q&A box at the bottom of your screen, so please feel free to drop your questions in there, and we'll get as many as we can at the end. So yeah, as I said, we're gonna do trivia at the end. And yeah, so I think I'm ready. Chris, can you take over the mic and kick off the day today with the talk?
Yeah, so hopefully this works.
Welcome, Chris. So Chris is one of our organizers. He's going to speak at KubeCons as well very soon. I think next week, right? So yeah, so happy to have you over, Chris.
Yeah, and I'm excited to be here. Sorry, I'm just trying to figure out how to share my screen properly. So first time presenting digitally, so this is little hang-ups here or there. There we go. So as Archie said, I'll be doing a presentation for KubeCon that's based off this. So this is a bit of a dry run, so any feedback would be greatly appreciated. So let's just kick this off. And if anyone can't see my screen, just drop a note in the chat, and I'll, till then, I'm just going to assume that things work. Yeah. All right. So this talk for managing multi-cluster, multi-tenant Kubernetes is something that I submitted back before I switched jobs, and so now with KubeCon having been delayed a few times, I'm no longer a Kubernetes administrator with my former company, but I'm now a customer engineer with Google Cloud Canada's public sector division, where I'm helping our local and federal governments adopt cloud and Kubernetes, which is really exciting. So I get to help a lot of people, which is I'm very, very excited about. So this talk was kind of born out of my how do I manage all my tenants. So I'm not sure what things are like for the rest of it there, but my environment was, as a Kubernetes administrator, we had multiple clusters, and then we also had multiple teams or tenants, right? So everyone wants to deploy to Kubernetes, and how to kind of keep things nice and neat, centralized, repeatable, and let the team still have their own autonomy, have their own CI, but have a kind of a controlled or common deploy pattern to Kubernetes without impacting them too much. So that's where this came from. So exciting to get in there. And right, so I'm coming to you from home. Normally I'm used to presenting to people. So this is my audience today. So hopefully I won't disappoint optimists too much, and we'll get on with that. So this is also an intro talk. So I just want to kind of cover off what GitOps is for people who are new to it or haven't possibly heard of it. So GitOps is a workflow process which treats your Git or source control as a desired state or a single source of truth for your infrastructure deployments. And Kubernetes is really nice with this, being that we have our Kubernetes YAML, which we declaratively decide what is going to run. And Kubernetes is great at that. You give it the contract and it's okay, I'm going to run that. So GitOps kind of builds on that, and you have an operator which sits in that cluster and monitors your Git repo at a specific tag or branch and deploys that for you. So the nice part about this is you don't have to, say, distribute your kube configs to all the new to the CI pipelines that all the teams are using. You also reduce the amount of people who have physical access to the clusters, so reduce kubectl. And then there's just Git being Git. You have increased auditability because all the changes are being done through PRs and issues that are being created. This also leads to increased visibility. This also helps increase collaborativeness, being that the entire infrastructure is stored in Git, so your teams can see the infrastructure, they can propose changes to the infrastructure. Things become much less of a black hole, which is nice. You're not deploying to a VM, which Bob might have a cron job running at 2 in the morning to reboot everything. That kind of stuff is not or surfaced within the infrastructure. And of course, our patron saint, Kelsey Hightower, he's also a big fan of this. So if Kelsey's kind of endorsed it, you know, it's not vaporware, which is awesome. So as I alluded or talked about briefly, this is just a high level overview of how GitOps in Kubernetes works. So you have an operator which sits in your cluster, monitors your Git, and essentially just does a Git clone every X minutes, depending on how it's set up. It runs kubectl apply, and then you get your infrastructure, which is great. And then there's a couple CNCF projects that you can use to employ GitOps. So you have Flux, which I'll be talking about today. And then there's also Argo CD. When I first ventured on my GitOps journey, Flux was the one that answered my usability questions. Argo is definitely a close second, so do take a look and see which one works best for you. But we will be looking primarily at Flux today, but hopefully the patterns will apply to both tools. This is the workflow for Flux. So much like the slide I showed you just a little while ago, we have a central agent which monitors a Git repo and then pulls the changes, talks to the API, pretty basic. The added bonus that Flux has is it can also monitor your container registry. So as your application developers push new images to the registry, it can see those tags and write those changes back to Git and deploy them automatically for you. So it's a nice little automated workflow. I found it works really well in dev QA. Production may want to have some kind of manual gating process on that. So now for the deployment structure. This one took me a little while to get to, a lot of research. So I'm hoping this will help you avoid going through the pains and reading that I had to go through. Sorry. Oops, there we go, sorry about that. So generally want to deploy, break things up into two repos just from a start. You have your application repo and then an application operator repo. So one will be focused on generating the actual containers or artifacts which you'll be your application will use. And then the app operator will be designed to basically just make sure your Kubernetes YAML is valid and conformant to your company policies if you do have any. So the intent behind the two processes is different enough. You want to keep them separate. And then you don't want to be generating a new container every time you modify your manifest. So it's just nice to kind of keep them in their own buckets. And this is an example of what that Kubernetes manifest repo would look like. There's just a folder with some CI stuff and YAML. So there's not a whole lot there. In the case of Flux, it'll just look at that repo, or sorry, that folder and just deploy all the YAML it sees in there, and then you get your stuff. So you don't have any extra added configuration, or you don't have to. The developers don't necessarily need to learn the tool. They just put the manifest in the repo, and then things get deployed, which is really nice. There's not extra learning for them. And then we get to the CI aspect. So we want to make sure that your CI is checking a few things: your security, validation, and then to see if you can actually run your YAML. So the tools that I generally lean to for this, so there's tons of tools out there you can use, but these are the ones we're going to focus on today. You have open policy agent and the Rego policy, the open policy agent and their Rego policy language. So you can write policy to validate whether or not, it could be deployed to your cluster. So making sure that containers are coming from the proper registry, making sure that you have your container limit set, or making sure you're not running as root, those kinds of things. They have a sub-project, or a new sub-project now, called conf-test, and that allows you to run these policies in a CI pipeline or even locally on your machine, so you don't need to have Kubernetes propped up to do stuff, which is great. And KubeVal, it's another project. It's done by the same person who created conf-test, Gareth Rushgrove, and its job is to determine whether or not the YAML that you have is API compliant with specific Kubernetes versions. So those two work really well together. And finally, we have KIND. And for those of you who aren't familiar with KIND, it stands for Kubernetes in Docker. And it's a nice little tool which allows you to spin up a small Kubernetes cluster in Docker. So it fits really nice within a CI pipeline. And this is kind of a skeleton or a bare bones pipeline that you'd want to look to employ. So first phase would be your validation, make sure your YAML is compliant, make sure it's secure or conformant with security policy. Second would be to actually test it. So in this case, you'd spin up a KIND cluster, deploy the YAML to that cluster, and then run some unit tests against that to make sure that things are as expected. Is it going straight to a crashback loop? Are the right number of pods popping up? Things like that, or even just making sure that the API response is what you're expecting. And then finally, your release phase. And this would just be a manual approval on the PR, just to make sure that you're not jumping the gun and automatically releasing a broken config into your production environment. And this is another area where I got kind of tripped up on when I was starting to work, put this together. So there's really kind of two ways you can do this, and they have their strengths and advantages. And so it's kind of that monolith versus microservice kind of argument. And the left here, we have a single repo, and this would be all the configs for the clusters are in a single repo. So you have security, all the different app teams committing to a single source. The other option would be that each of those teams has its own repository where they keep their configs. They have more control over what they're doing, their own independent CIs, instead of a kind of a massive one that checks everything. So for smaller teams, single repo might be better, but for larger, more distributed teams, a multi-repo process might fit that a little bit better. So it depends on your environment and what you're trying to accomplish. Given the environment that I worked in, the multi-repo would fit our work case a little bit better. So I'm just going to walk through how those are set up. So in the single repo setting, we're just going to have a bunch of folders. In this case, we have a folder for cluster admin, and then each team has its own subfolder. So depending on how your organization is or team is organized, this can be however you want. The idea is that all the teams, they commit to that cluster, that Git repo, and then the changes go from there. So for a multi-cluster environment, we'd be looking at each branch or tag would represent a specific cluster or range of clusters. And then you deploy the agent to those clusters and tell it to sync with a specific branch. So in this case, we have dev cluster, which is going to be syncing with the dev branch, prod, which is going to be syncing with the prod branch. So that is more or less how you detain multi-cluster, multi-tenant with as just a single repo. Now for a multi-tenant or a more broken down deployment or view for the multi-repository version, you'd have and this is adapted from the Flux multi-tenant repository. So you'd have a cluster-wide repo, or sorry, agent, which would be in control of all the cluster-wide resources, so your namespaces, quotas, pod security policies, and it would also be in charge of configuring sub-agents, which would sync up with the independent team or the team's repositories. So the cluster-wide repo, that would be the purview or in the domain of cluster admin, And then the other agents would be oriented for the teams, and those would be namespace. So if someone wanted to change, their RBAC or pod security policies to try to circumvent what the admins put in, it wouldn't be allowed because they'd be restricted in terms of the PSP and their scope, which is really nice. So you give the teams a lot of autonomy, but you also have them kind of boxed in so they can't overstep what they're supposed to be doing. And the other, so I mentioned this a bit earlier, but one of the things I found was really nice with this process is certain repositories or groups, we had more of would need to affect multiple clusters. So it started looking at branches or tags equating to a group or an environment of clusters. So what I like, the example I've been going to a lot recently is, say, security. So security may have different bands or sets of policy. So let's say PCI or high, medium, low, depending on what kind of networking environment that you're looking at or how security's been broken down. So in this case, security team would commit to their security repo at whatever branch or tag that they wanted, and any cluster that equated to that or fell within that branch's scope would automatically inherit those policies. So if you or I as a cluster admin was bringing online a cluster, and I knew it was a high security or it was supposed to be in the high security environment, you just need to make sure that it's syncing with that target repository and it would get everything. So that's one of the other nice things about GitOps, especially with things like Flux and Argo, is they're pull-based. So we wouldn't have to go and update the CI for that security team to affect the new cluster. We just have to make sure that the agent that we deployed had the right SSH key to access the repository. So there's less configuration to manage, and you also so this allows the teams to affect a far wider group of clusters without having to micromanage their kube configs in the CI, which is really quite powerful. And of course, bringing a cluster online or even doing a disaster recovery if for some reason you lost all of your clusters, you have all your state already stored within Git, probably already have the SSH configs ready, so you can just bring out the clusters, sync up with the existing infrastructure, and you have your stuff back, which I think is super amazing and quite powerful, especially if you're trying to manage a lot of clusters. And so this is what that folder would look like on the Flux side. Other agents might do it a little differently. So here we have in the cluster folder, sorry, I should have highlighted that red, but it's just right here if you can see my mouse kind of squiggling over it. So each team is going to get their own folder here, and the information, the YAML that's in there describes the Flux agent, as well as any of the cluster level of resources that are going to be a part of that project. So PHPs, quotas, namespace, that kind of stuff. And again, you just ad nauseum for each team. So it can get a little big, but it's not going to be as big as the single repo tree structure. So we'll have a little bit more control. And this is what the agent would look like for the configuration. So you tell it what namespace it has access to, as well as what repo it's going to, and then the target branch. So not a lot of extra config, just where am I going, what am I syncing with, how often. That's pretty much it there. And then question that comes up a lot, how does Helm work? Because this is just using kubectl or customize, things like that that are built in. So thankfully the Flux team has created an operator which helps manage Helm charts. So it uses a CRD called a Helm release. It supports both V2 and V3 of Helm, and one of the other nice parts is it's not dependent on Flux. So if you're using something else, you can easily adopt this and go ahead, which is awesome. And this is on the right what it looks like. So you just have your CRD config at the top, and then down at the bottom you have your values. And I just triggered Siri somehow. So you just, yeah, so the values is just the values file. Is inline YAML, which is pretty sweet. So that's my quick little high-level overview. So for managing multi-clusters, GitOps helps you simplify the process. It's a pull, not push. Keeping your application and the YAML in separate repositories really helps keep things organized. Of course, use multiple repositories for any teams that need higher isolation, and branches and tags help match cluster profiles to environments, so you can affect a large swath of clusters from a single location. And so for me, I'm Macintosh Prime at most places on the web, Twitter, Kubernetes, Slack, as well as the Canadian Kubernetes community. I've also dropped a couple of resources down here. So I'm really excited for the next talk. I put one of Steve Wade's articles here about how they do GitOps at Mettle. It's a really good read, and hope and his presentation is going to be pretty solid. And I'm very much looking forward to it. And that's it.
Well done, Chris. Thank you so much. Good luck for your KubeCon talk. We're looking forward for it, and let us know how it goes, your virtual experience with KubeCon.
Currently on take 100 of filming it, so.
Yeah, I have a ticket, so I'll definitely come support you. And
awesome. There'll be new content, so it's not going to be exactly this. So there's still stuff, there's a carrot being dangled.
Great. So I'm checking if there's any questions on the Q&A box.
Oh, yeah,
okay. Yeah, it was just only the question about recording. Yes, the event is recorded and it's going to be available at the Slack channel. We're going to post the video, and it's going to be at our YouTube channel as well. So you can, if you need to drop off for some reason, you can check it out later as well. So no worries with that.
Got a question?
Yeah, one question. Okay. Oh no, it's thanks from Sebastian only. Yeah. So I guess let's. Keep the questions maybe for, once Steve will cover, I'll let you guys both answer, because you guys covering the similar topic, around Flux. So, maybe will people still need some time to warm up and get the questions going? Let me check if there is, no, not yet. All right, so we'll go forward, and then we'll have a bigger stop after Steve finishes, and then we'll try to make a little bit more discussion maybe, and interactions with each other on that type of topic. So, Steve, welcome back to Canada. Happy to see you again.
Thanks, man. Pleasure to be here.
Yeah, we're super happy to see you again, and you've been one of our supporters from the day one, and you came all over the way to Montreal, I think, last time. And now, since we're doing things online, it's so much easier to get you on board and in a good timing zone. So we're always excited to hear from you and what you're doing. You used to be, I think, consultant. Now you're working in the company. So yeah, let us know what's going on there.
All right. Firstly, can everyone see my screen?
Yes, you're good.
Okay, cool. So I'm gonna kind of spend the next 30 minutes or so touching on the implementation portion of what Chris has been talking about. So Chris talked about some of the theory behind GitOps, some of the tooling that's available to you, but how do you actually use that in the wild? And this talk is going to be about the journey that myself and the team at Mettle have been on, embracing GitOps, what it's given to us. So my name's Steve Wade, as Archie alluded to. I'm an independent consultant and trainer, and platform lead at Mettle. I've been there about 2.5 years now. So I've contributed to a couple of projects. One of them you'll know because Chris literally just talked about it, Flux. And I've blogged a lot about this. Chris even put some stuff on his slides. Thanks, Chris, for that. About this in a lot more detail. So this is going to be relatively high level. If you want to know kind of technical detail, go and check out those blog posts, reach out to me on Twitter or in the comments of those blog posts. I'm more than happy to help you. So let's start with what is Mettle. So Mettle is a way for businesses, small or medium enterprise businesses, to be able to perform banking. But there's no bricks and mortar, so you can't go into a Mettle branch. It's done on your mobile phone via an application, and it allows you to do things such as raise invoices, reconcile receipts, and look towards the future of how you could use your money that your business is making in an efficient manner. So I want to start with this slide. So Kelsey said this quote in 2018, which is, once you found success, your next goal should be helping others to do the same. So I'm going to replace success, and I'm going to say that it's a pattern that works. And at Mettle, we found a pattern that works. And I want to show you how that pattern could work for your organization and the benefits that we've got from that. So it's quite a packed agenda. So I want to start with the unanswerable question. There was a question that was asked to me when I joined Mettle, and I couldn't answer it, and the team couldn't answer it. And then we went on this kind of redesign process for us to be able to allude and provide an answer to that question. Then I'm going to talk about how we structure our repository. So it will touch a little bit on what Chris has talked about, but it will go into a little bit more detail. We have a couple of other repositories for a few different things. Then we'll talk about continuous delivery. So how do we make application changes, but also how do we make YAML changes? Because those two things are slightly different. Then how does it all come together, right? So we've got all these repositories, and we've got Flux in place that can reconcile those repositories, but that's great. Well done, Steve. You've created 6 repositories and you've got Flux pointing at them. But how does it all come together, and what does it give us that it didn't give us before? And then we'll touch on GitOps. So it's all the stuff in GitOps that people don't want to talk about. I'm going to tell you how you can really, truly, royally mess this up. We've done it, and I don't want you lot to have the same problems that we had. And then finally, can we answer the question now that we couldn't answer before? So when I think of investment banking or banking in general, I think of guys in suits looking a little bit like this when they've made, when they've helped their customers. But actually what we need to think about is this, right? There's a lot of red tape around those organizations, and they can't move fast. And that's why Mettle was kind of span up inside of a normal bank, for us to be able to show them different ways of working and provide them with processes and patterns that can hopefully enable them in the future. But because of that, we got a lot of this. So assume these people are all of the people that are working in the bank. They've got the microscope out. They're looking at us. Look, what are these guys doing over here? How comes they don't have to comply with all these policies and these regulations? And this happens. So we get asked a lot of questions. Replace Mark Zuckerberg with myself in this context. And the question that we got asked, and it was about 18 months ago, maybe 2 years, was, how long would it take you to rebuild an environment? And this was my response: I don't know. Why don't I know? Well, I don't know because we've never tried. Why would we try? We have this perfectly running Kubernetes cluster that manages workloads for our customers, and engineers can deploy to it. What's the problem? Well, things will break. And for me, as a kind of lead in the position that I was in, to have this conversation with, the then CTO and other members of the wider bank, and giving them an answer if I don't know. The question is, well, what are you doing over there? You're supposed to be showing us new ways of working. You're supposed to be showing us new patterns. One of the things that we have to align to in the corporate bank is being able to show disaster recovery. And now you're over here telling me that you don't have it. So now we've got a bit of a problem, right? The microscope is even more out on us now, because we need to come up with an answer. So this is where the rebuild comes in, and we essentially reset the clock, started again. And we started that based on a mission statement. So the mission statement is this: so to provide an easily recoverable, that's going to sign off the first question that I had. Consistent platform, consistency is key, right? We want all of the environments to look the same, allows developers to be able to ship features. Clear ownership, or I as a platform engineer don't want to look after your applications, and you don't want to look after the platform, right? So how do we divide this up? And that's where kind of Chris's talk about multi-tenancy is going to start to come in. And then the most important thing is to be self-service for developers, right? The platform team should be focused on the platform. The developers should be focused on shipping features to our customers that differentiates us between our competitors. So at a high level, what does this whole thing look like? So we run out of Amazon, and then on top of Amazon, we have this Kubernetes layer. And then on top of Kubernetes, we just essentially want to deploy the Mettle workloads. Simple, right? That's essentially what we're building. So now we've got a couple of choices to make. We've got the Flux choice, or we've got the Argo choice. We decided to go with Flux, and you've seen this diagram before. Chris showed you it earlier on. The reason why we decided to go with Flux is mainly because of this sync method, right? We've got this bidirectional sync now, syncing that can happen from the Git repository, but also from container images. And actually, it was very simple to understand, right? We already had Helm charts. The application developers had hundreds of them, trust me. They were all different. They never really looked the same. So we wanted a way of easily being able to embed the GitOps process into the process that developers are already working with, right? We didn't want to cause all of this, noise and make them change large areas or components of their pipelines. We wanted to hook this pipeline or this kind of practice or process into their existing pipelines and keep them working at the same speed. So we're going to get this easily recoverable now because we've got this Flux instance or multiple Flux instances that we'll come on to shortly that sit inside of the Kubernetes cluster and are going to reconcile our desired state. So a key thing to note here is that GitOps is around desired state, right? You are declaring the state that you'd like the system to be in, and Flux or Argo CD or other agents are going to try their hardest to get you in the position that you've declared. It's very similar to Kubernetes. Kubernetes is a desired state configuration, right? All we're doing is we're making sure that rather than backing it with a CI machine, we're now backing it with Git. So now on to consistent platform. So how do we get consistency? And we talk about this 3-character environment prefix. And we're going to use that for DNS. We're going to use that for the GitOps repository structure that we're going to come on to shortly. And we're going to use that when we talk about microservice image tags. So this 3-character prefix flows throughout everything that we do at Mettle, right? From an engineering standpoint. It is paramount to the way that we deploy. It's paramount to the way that we stand up infrastructure. And we're going to come on to that in the next couple of slides. So now we've got this consistent platform, we've got this 3-character environment prefix that we are going to maintain throughout everything that we do with the platform. So now the next thing to come on to is clear ownership. And this is where I'm going to talk more about what Chris was alluding to with this multi-tenant. So how do we at Mettle structure our repositories? So as I talked just a second ago, before in our old platform, application developers would deploy their own Helm charts. And as you know, with application developers, they love to copy and paste, but sometimes they copy and paste stuff that's wrong, right? So now what we want to do is we want to take that burden off of developers. We want developers to focus on business value. Creating YAML files is not business value. It is the means to ship features. So now what we're going to do is we're going to create a back-end chart, a back-end Helm chart, and we're going to allow all of our application developers to leverage that back-end chart. So in our Helm release that Chris showed, you're going to see that they reference the back-end chart. And then all the developers have to do is understand the interface or the values.yaml of a normal Helm chart. And that's their abstraction to onboarding microservices. Then they have to understand a couple of annotations, which we'll come on to in a second, and away we go. We're at the races. So here's a Helm release, and Chris has showed this before. With Helm releases, you can get annotations. In this example, we're saying, okay, for this Helm release, I want you to perform automated image upgrades. So this automated annotation line here is specific to the image. And then we're saying for this image, every time you see an image tag in the repository below that aligns to this semantic version, I want you, Mr. Flux, to deploy it for you, to deploy it for me. So that's what the CI machine used to do, right? But now we don't need the CI machine. The CI machine is going to be focused on doing CI. Now Flux is going to be focused on doing the deployment, and we've disconnected the two. So when people think of CI/CD, there was always that slash, remember? CI/CD. So now what we've done is we've split them apart. We've got the concourse pipelines that are going to allow us to do CI and testing and automation and everything like that. And then we're going to use Flux as our way of doing CD. So let's start at the first repository. So our first repository that we have is Kubernetes resources. And this repository is for platform engineers, and it contains a number of different components, but think of things such as the logging stack or the monitoring stack, or all of the role-based access control that allow developers to see certain areas of the Kubernetes cluster, but not others. All of that is done within Kubernetes resources. So within Kubernetes resources, we use a product called Customize. So if you're not familiar with what Customize is, it essentially allows you to create a kind of base configuration for a YAML file. And then you have this concept of patches. And what a patch does is it kind of does a Git merge, if you want to think about it. And you merge your environmental changes with your base or kind of core level changes, and that is what gets deployed to the Kubernetes cluster. So I've left a link down here if you want to kind of look at Customize in more detail. Flux supports Customize out of the box with a couple of configuration flags. So let's take a closer look at Kubernetes resources. So we start with Customize, and then inside the Customize directory, we have this underscore modules directory. So this underscore modules directory is going to be everything that is non-environment specific, right? And then inside the environments, we are going to override, or we're going to patch those configuration files with environment specific metadata. So you'll see here, and you'll notice we're back to the 3-character prefix, and then we have some 2-character prefixes as well. So those are for personal environments. And then at the bottom, we have a tools environment. I didn't want to shorten that to TLS because people are going to get confused with certificates. So then inside modules, we have a number of other directories, and those directories could be around a number of different things. So the RBAC and the pod security policies that come out of the box for EV. So EV is one of our products, or the namespace that's required for identity, or our ingress controller that we deploy. But let's take a look at Istio. So we've got Istio 163. So we've got that in base, and now let's look at dev. So what we say is, as we alluded to before, we deploy everything with a Helm release. So this is the Prometheus configuration for Istio in dev. And as you can see, all we're doing is we're overriding what's already there in the base configuration with environment specific config. So that's Kubernetes resources. So now what about secrets? How do you handle secrets, right? This kind of unheard of, unanswered question. So what we use is we use a tool called sealed secrets. So Flux plus sealed secrets equals awesome. So now what we can do is we can deploy and manage sealed secrets in Git, right? So we have a Kubernetes secrets repository. And how this works is the public keys live in Git and the private keys live in the infrastructure. So you seal a secret with your public key for your environment, and then the only thing that can unseal it is the sealed secrets controller running in that environment. And we have all of this configured with Terraform for us to be able to create private keys and be able to rotate them, et cetera, et cetera. So now we've got Kubernetes secrets stored in Git. Here is the repository. And then over on the right-hand side, we seal the sealed secrets directory, again, with our 3-letter environment prefix. You can now see how this is flowing through all of the repositories. Okay, so we've now got a basic set of workloads for us to be able to run the cluster from a monitoring and logging and ingress perspective. That's great. We've now got a way of being able to store Kubernetes secrets. That's also great. But Steve, what about the workloads? So now this is where we have K8's releases Mettle, and this is where all of the Mettle workloads live. So again, they're using Customize. But now inside the Customize directory, you'll notice it looks a little bit different. So they've got base. Base is what we were using, exact same replica setup as we were using, but we had modules. And then again, they have the 3-letter environment prefix. But notice here how they only have the ones for the long-lived environments, or the environments that these Mettle workloads are going to live. They don't need the personal sandboxes because they're not going to deploy to them. So let's take a look at the base directory. So again, the base directory, non-environment specific configuration. So in the base directory, we have a number of subdirectories. These directories are around different products or different tools. So EV is a product, identity is a product, SSV is a product. And then we have some other components that do or don't get deployed to set specific environments. So the key thing to note here is the abstraction that we've done in base is around areas or products that get deployed to different environments. So as an example, in tools, I don't need to run EV workloads. So EV needs to be its own subdirectory that inside the environment directory, I either choose to use or I choose not to use, right? So it's now kind of like a pick and mix in terms of what workloads get deployed to what environments. So let's take the account balance microservice inside of EV. So you can see here that we're pointing at the backend chart and we're giving it a release name of account balance. The key thing to note here is that the release name needs to be unique cluster wide. If they clash, Flux is going to get itself into a complete mess. You'll notice here that there's no chart version. And the reason why there's no chart version is because the Helm chart is specific to the environment that we're deploying in. So for those of you who remember, 1.16 deprecated a lot of APIs. So we had a 1.x chart that was for prior to 1.16 releases. And then we had a 2.x chart that was a chart that could be deployed to Kubernetes 1.16. And then we had some CI wrapped in that, where we looked at all of the Helm releases for a given environment. And then if they were all at 2.x, we knew that they were ready for the 1.16 deploy. And then we were able to roll out new environments to 1.16 by bumping the chart version in each discrete environment directory. The other thing you'll notice is the image tag is not at the base directory as well, because the image tag is environment specific. So that's the base, right? The base is the non-environment specific configuration. So now, Steve, what does the environment specific configuration look like? So let's dig into dev. So you'll see here that it looks very similar to what you saw in the base directory, but the difference here is that we pick and choose what products we want to deploy to that environment. So in dev, EV Helm releases, we have the account balance Helm release. So now you'll see that we've got this tag, and now we're doing tags on globs rather than semantic versioning. So what this allows us to be able to do now is this environment prefix is now flowing even into image tags, right? You'll see it here. So for us to be able to deploy a new version of account balance to dev, we need to create a new image tag with the dev dash prefix, and this value down here underneath tag is just the long commit SHA. Upload that to the image repository, and then Flux is going to do the rest for us and is going to deploy it, right? So all we're doing here in this Helm release is specifying how we want it to work now and in the future, right? We don't need to make any changes to this. Any changes that we now make to this Helm release are going to be maybe another environment variable because you've added an environment variable for a new feature. But this is kind of the skeleton of how all of our Helm releases look across the board. Then finally, the chart version, because that's the chart version that we're going to deploy and we're going to use to deploy this microservice to. You'll notice at the root of customized dev, we have this Flux patch. So what's this Flux patch doing? So I said before, we upload a new image tag to the image registry, and Flux is going to pull that down and going to deploy it. Once it's deployed, it writes back to Git. So now we have an audit trail of all the changes that have been made to Mettle workloads in all environments since we first stood up this pattern or this kind of environment platform. That's pretty awesome, right? I had to put the Queen in here. I'm from London. We have to represent the royals. So this is awesome, right? So we've now got this way of being able to deploy, but now how do we do continuous delivery? Steve, how do you actually ship features? So I want to start with the microservice pipelines. So let's take an example. Let's take account balance. So account balance is wired into Concourse. The developers use Concourse for their microservice pipelines. And we do a Docker build. And we do a Docker build at dev-commit SHA. And then we do a Docker push to our image registry. So in our example, it's GCR. So we've now got a new image tag sitting in our image registry. And we know from the previous couple of slides that Flux, if we set the annotation, is going to be looking for new image tags that match dev-star. So Flux sees it, patches the Helm release locally. So the key thing to remember here is that the Flux pod contains what is in Git. It then patches the Helm release locally to its pod, performs the kubectl apply to the cluster, and then finally writes the changes back to Git, telling you that it's done it. Whilst that's happening, because all that's happened in Concourse is they've just pushed the image, they now talk to Kubernetes, and we have a nice script that essentially makes them sit in a wait loop. And all that wait loop is doing is how we deploy with our backend Helm chart is we have a specific label that is app_name and app_image version. And what it's looking for is their microservice, and the version is the image tag that they deployed. So they're looking for dev-123. So once that's deployed and it's passed the deployment, they then go on to testing. So they're going to test the version of the microservice that they want to deploy. They're going to run their contract test or whatever test they want to run. And then when it comes to staging, they just re-tag the same image, but with stage-commit sure. And then it's just test, rinse, and repeat all the way to production. So what does that give us? Now the developers are focused on the thing that matters the most to them, the testing. We've now templatized the pipeline in such a way that the image creation, image upload, and the wait for the new microservice to be deployed is all standardized. So now they focus on the CI, and that's the bit that affects a customer having an outage or not, or someone not being able to log in. So they're now focused on the area that they should be focusing on, the CI portion. Flux is going to take care of CD for us. So now that's microservice changes, but now what about kind of Kubernetes manifests? So we have GitHub here for our repositories. So think of K8's releases Mettle, or think of Kubernetes resources. And we use Circle now because there's no need for us to use Concourse, because we don't need to have inter-microservice communication tests. So the first thing we run is conf tests, and we basically are checking against and making sure that we're not using deprecated APIs. So we're running Kubernetes 117 Mettle, but we are testing and we are ready for 120. So we can go all the way to 120 and know that our YAMLs are going to work. Then we run kubeval. So what kubeval does is allows us to be able to validate YAML files against the upstream Kubernetes schema. So we do this in strict mode. So that stops a developer from adding a new flag or a new kind of portion to a deployment that shouldn't be there, and nor is it going to be allowed. And then the final one that we do is HRval. And if you don't use HRval and you're using Helm and kind of Flux, this thing is awesome. So what it does is it takes your Helm release, it goes and gets the chart that you are going to use in your Helm release. It blends the default values from the chart with the values in your Helm release, does a template, and then runs kubeval and conf test against it. So the first two, if you think about it, the deprecation check and the kubeval check, are really doing deployment based. So think about Helm releases, Helm charts. That's where they're going to become really useful. And then for RBAC and stuff like that in Kubernetes resources. But in K8's releases Mettle, we have to make sure that the Helm release is going to work. And that's the thing that gets deployed to the cluster. So in Kubernetes K8's releases Mettle, it's all around kubeval. This is where we do the dry run and really validate that before we get to the Kubernetes cluster, we've got confidence that at least the YAML or the manifests and the resources that are going to get deployed actually work. So this is great, right? Congratulations, you've got all of these repositories, you've got a load of, you've got a Flux instance, you've got a load of CI. Well, that's great, but let's go back to the question that we were asked before. How long does it take for us to stand up an environment if we're in an incident? So now we've got a way of being able to deploy changes. So the next thing that we need to fix is this bootstrap process. So we deploy in Amazon using Terraform, and we deploy Kubernetes on top using Bootkube. And what Bootkube allows us to be able to do is pass a set of manifests at bootstrap time that we want to deploy, right? So spoiler, we're going to be deploying as part of that bootstrap mechanism a Flux instance. And that Flux instance is going to point at, yep, you've guessed it, Kubernetes resources. So that's the first Flux instance that comes up, and it comes up as part of Bootkube. So if the cluster comes up without Flux, it's not a cluster that works. We have to get at least this far. So for Kubernetes resources, we are going to point at a repository, we're going to point at a branch, and we're going to point at a Git path. And as you can see here, the three-character environment prefix is all the way back to the Terraform that we execute to stand up the cluster. So if any of you were kind of keen-eyed and saw when I was showing you this modules directory, you would have noticed this. This is a directory for new fluxes, right? Because we have other repositories that we want to stand up now. So inside here, we have a bootstrap flux. That's the flux that gets deployed with Kubernetes resources as part of Bootkube. Then we have engineering, and that's where we do our K8s releases, Mettle. And then we have other ones for Istio resources and Kubernetes secrets. So what that gives us is the first time Kubernetes resources comes up, when Flux finds it, it's going to find all of these other fluxes. So now we've got K8s releases Mettle. Eventually, that's going to deploy all our Mettle workloads. We've got K8 secrets. That's going to deploy all our Kubernetes secrets for us. We've got a Kafka topics repository, and that's going to deploy all of our Kafka topics for us. We've got our K8's network policies, which is going to deploy all our Calico network policies for us. And then our Istio resources, which is going to deploy our Istio configuration. And all of this works on some directory / that environment prefix. So that's great, right? You've got all this great stuff, Steve. You know, you're doing really well, but actually, like, can you tell me about this stuff that didn't work so great? And this is the stuff that no one really tells you about. So how can it go horrifically wrong? So what you could do is you could run multi-tenant Flux and Helm, like Chris was alluding to, using Helm 2. So for any of you that are familiar with Helm 2, you'll hear this awful word, which is tiller. Trying to get the RBAC permissions, or the role-based access control permissions, for tiller in a multi-tenant environment is an absolute nightmare. What I would recommend you do is you go straight to Helm 3. If you haven't gone straight to Helm 3, I've blogged about the upgrade from you to be able to go from Helm 2 to Helm 3 and start your multi-tenant journey or your multi-flux journey using Helm 3. Don't try it with Helm 2. It's really not worth the headache. Trust me, I lost a lot of time and a lot of nights over that. The other thing to note as well is when we talk about the Helm operator is obviously looking at the Helm releases that Flux is deploying. So Flux is declaring your state, your Helm releases, but the Helm operator is the thing that's turning your desired state into actual manifests that get deployed. Be careful if you're running at scale, but with using one Helm operator for everything. I would recommend having a Helm operator per namespace. You'll get faster deploys and your developers will be a lot happier. So in terms of Git oops, how can it go horribly wrong? Again, don't do multi-tenancy with Helm v2. It's not worth the pain. Go to Helm v3. And I would recommend going with a Helm operator per namespace. The reason why, if you've got nice RBAC permissions and you only allow developers from a multi-tenancy perspective to see the namespace that they're deploying into, well, now they can see the Helm operator that's being used to deploy their applications. So the million-dollar question, can we actually answer the question that you got asked, Steve, 18 months ago? Yes, we can. And now I'm happy to say that we can rebuild an environment in 25 minutes. And by that 25 minutes, that's one Terraform apply pointing at the right Flux repository, at the right directory. And in 25 minutes time, Flux is going to do absolutely everything else. And all those fluxes are going to come together, and we'll eventually get a running environment with a handset that's able to connect and you be able to see your invoices. So in short, mission accomplished. They asked the question, it took us 18 months to get there. And now we have a way of being able to deploy clusters and be confident in our methodology. And the other thing I want to talk about just very quickly is we're so confident in this, we tear down the cluster every night at 9 o'clock and we stand it up every morning at 8 a.m. in every single environment all the time, obviously apart from production. So we're constantly dog fooding this exercise. So we now know with confidence that this pattern works. I'll leave this on the screen for a couple of minutes. Top half of these links are links that you'd want to use if you're using Flux or Customize. Bottom half of these links, a GitOps with Customize, which is an example repository, which if you're new to this journey, I'd recommend you check out. It's going to give you some kind of useful CI that I've mentioned. It's going to show you the directory structure. And then at the bottom, I've blogged about this quite extensively. I know Chris has read quite a lot of the blog posts. Feel free to have a read and reach out to me if you've got any further questions. And that's it.
Awesome, Steve. Thank you so much. I hope everybody's clapping now, like me. Thank you for sharing insights. I mean, usually people are not, so proud of telling what they're actually doing. And, this is like really, really deep into what you guys have done so far. And thank you so much. I hope a lot of people will find this useful, as I am right now. We have a few minutes for the questions, and we need to kick off the next speaker, Owen. There was a few questions. Some of them has been answered. And Chris, Steve, you can both pitch in if you would like to. So Gary is asking why you use Customize instead of Helm for Kubernetes resources. Steve, you want to take it?
Yeah, sure. I can take that. So if you go back to what I was saying with the earlier platform, right? Developers had a base understanding of Helm releases, of Helm charts, sorry. They had a Helm chart per repository or per microservice. So now all we've done is we've taken up all of the good practices. So think about consistent labeling taxonomy, think about horizontal pod auto-scaling, all the things that application developers don't want to think about. They're not Kubernetes gurus. They don't need to think about Kubernetes. All they now need is this values file, which is their abstraction and their interface to deploy microservices. And then the reason why we use Customize is so that we can dry up the repository. That's all we're doing. We're drying up our repository and allowing changes to happen at a very discrete cadence. And the Helm chart is the thing that is tightly coupled to the environment where it's getting deployed. So we will take, from a platform engineering perspective, we'll take concern and ownership of what that looks like. We've got a README that essentially you can go down and it will show you all of the values that are available to you, what they do if you turn them on and off, et cetera, et cetera. So now what that's allowed us to be able to do is, as a platform team, we've taken a step back, right? They understand values files. They know how they work. They know where to go and get the Helm chart from. They've seen Helm charts before. All we're doing is we're taking all that Kubernetes knowledge and bundling it into a single chart. And then we're allowing them to be able to deploy microservices to their environment, to the environment. So prime example, brand new project, brand new team kicked off. They had 15 microservices into production in a week, and they didn't even tell me that they were doing it. The only time they spoke to me was for me to create a namespace for them. That's it. And that is exactly what we want. Application developers shipping features to our customers and the platform team being responsible for maintenance of the platform. So the decoupling there is perfect. And we use that Helm chart as the interface.
Yeah, and so using both Customize and Helm to kind of to summarize.
Yep. Mm-hmm.
Great. All right. Okay, so I think those other questions has been answered. Need to modify a few resources in cluster for emergency. Okay, if for some reason need to modify a few resources in cluster for emergency, does FluxCD can handle three-way merge?
Can Flux handle a three-way merge?
This is I think a Helm.
Yeah, so I
Helm,
think that's like if you're
terminology.
Yeah, so if you're trying to debug it in flight, like if you make changes in a live cluster, they're going to get overridden.
Oh yeah,
So
yeah.
yeah,
That's the great thing though, right? Because Git is your source of truth. So no more can you go in and tinker. You can, the automated, one thing you can do is that automated annotation that I showed you in the Helm release. If you set that to false, that's going to stop automatic deploys immediately. As soon as Flux sees it, it's going to stop them. You can do that. You can do as much as you want. But the one thing to note is that Flux is going to reconcile whatever's in Git. That's it. That's its job. So if you go and change the number of replicas in your deployment with kubectl edit to 3, and Flux has got it in Git as 2, 15 seconds or however long you've set the sync period later, it's going to go back to 2 again.
Great. This is, I think, a very popular question, and I think me and myself included we're interested about it. Does Flux have support for managing secrets with Vault?
Yeah, it does. You can use, there's a number of different backends. So you can use like SOPs by Mozilla if you're familiar with that. Yeah, there's a number of them that you can use.
Yeah, if you can type in answers while we are going to be, going for the next speaker.
Sure,
Can we do GitOps without any Helm? Of course you can, right? You actually don't need Helm for GitOps. It's just that for the people who is already using Helm, there's a way to use it with GitOps, right? So some questions without using customize. Same question without using customize. Okay.
Like the whole point is that all Flux is doing is reconciling a repository, right, in Git. If you want YAML files, straight up YAML files that you copy and paste everywhere, and that's how you're familiar and understand, then it will reconcile those. If you want to use customize, it will reconcile those. If you want to use Helm and you want to use the Helm operator, then the Helm operator can do that. It's horses for courses, right? The whole point is, and the whole value of GitOps is declaratively declaring the state of the cluster that you want in a centralized location that most importantly outlives the life cycle of the cluster. That's the most important thing. It doesn't matter what you choose. There's plenty of options. It's the same thing with choosing different CI tools, right? There's different ones and different people choose different options. The real value is where you store the manifests. That's all GitOps basically is.
My perspective was that, platform engineers, DevOps people that, they can use Helm primarily with Flux to deploy your cloud native applications like, Prometheus and all this stuff. And then the application developers, they would probably more going to be geared towards customize to, why you need another layer of the packaging. If you have a code, if you just need to deploy a Kubernetes manifest, why would you need to have a packaging mechanism? But that's my vision. I don't know, Steve, do you agree with that?
No. The reason why I say that is because you want to keep the cognitive load down, right? So if I can, so the prime example is the journey that we went on. We embraced customizing in the platform team. We derived a directory structure that worked, and then we essentially took and helped the developers, the application engineers, and moved their uncustomized repository to customize. And because they had something that they could always come back to, they now know how it works, right? If you have one, you can do it. You can have one way of deploying platform level workloads and another way of deploying application level workloads. But you've got two different paradigms. And when there's an incident, and on the incident huddle is an application developer and a DevOps or a platform engineer, if there's some common understanding of how changes get deployed, it's going to make your life much easier. Otherwise, you have to go, oh, well, you're an application developer, so you're not using customize, or you are. Well, I'm not. Okay, so I now need to think about this slightly differently. So for us, it's about keeping the cognitive load down, keeping it as simple as we possibly can. And then it's going to be beneficial for everybody, right? Play out the incident scenario where you're both on a call and you're both trying to debug something. The easier it is to get changes into the cluster, no matter whether it's an application workload or a role base or, a cluster role binding. If it's exactly the same mechanism, everybody can understand it. A platform engineer can easily approve a developer's PR and vice versa, because they understand the flow. The interface is Helm releases and customize. And if they understand those two things, that they commit back to our repositories and we can commit back to theirs.
Sounds great. I think the last question before we go to Owen, if the images are tagged using SHA, how does Flux know which one is newer dates?
So it works on timestamps. So if I go back all the way to the beginning, there was a memcache pod that was next to Flux. So what Flux is doing is it's looking for new image tags and it puts them in memcache. And then every time it sees a new one, it deploys it. So it's all based on the timestamp. So the most recent one always wins.
Great. Thank you, Steve, so much. I hope you'll stick around. I don't know how late it is right now there back in London, but amazing talk. Thank you, Chris, as well. So, if you can answer other questions that are coming, would be great. And, in our agenda right now is Owen speaking about Grafana Loki. And, after that, we're having Kubernetes trivia. So we're going to draw the prizes, Kubernetes hoodies for the best, knowledgeable people around Kubernetes. So please stay with us. I know you might need to drop off, but, if you want to stick around, learn about Loki and win some prizes, please stay with us. All right. Back to you, Owen. Welcome.
Thanks. Hi, everyone. I'm Owen. We'll see how much of this I can get through. So I'm here to talk about Loki. Can everyone see this? Everything good? All right. Assuming everything is good. So I'm a software engineer at Grafana and a Loki maintainer. And this talk is kind of decomposed into, I guess, two sections, right? The first one will go over what Loki is, why it exists, right, and the problems we hope to solve. Then I'll splice in a quick demo, and then we'll kind of jump into some of the internals, which I think will be pretty fun. So first of all, we've seen this big trend towards like logging, basically to drive analytics, right? So huge amounts of structured logging analytics tools, but that's kind of left, your general developer or debugging use cases, right? Your ops team, incident response, that sort of thing, a little high and dry. And so we want to build something that's just simpler and more developer focused, that solves log aggregation. And we're not the only people to kind of have this sort of idea. There's a bunch of other tools that take, very simplistic approaches that don't index the logs at all. And one of the tack-on benefits here is that it's a lot easier to operate and scale these sorts of systems. So this is one of our kind of blessed workflows, I guess. It's something that we use a lot. And so here you'll have, maybe a Slack integration for Prometheus Alert Manager. They'll tell you, what alerts are currently firing. And, if you're on call, you'll click through that. Maybe it'll send you to a Grafana dashboard, monitoring Prometheus. And then you'll be able to figure out, which applications or, which parts of your stack you're really looking at and which time periods. And maybe you'll make some custom queries to drill down even farther. But the part that we're really interested in is this translation, right? Taking these metrics, when you've identified, where the problem's coming from, and then translating into the actual application logs from, those instances for those time periods. But then going even further, then you may click through, extract things like trace IDs, and we have integrations for, like Jaeger, for instance, which is what this is. And then you kind of look through distributed tracing and figure out exactly, what part of your application needs to be fixed or changed or what have you. And then you go and you write your fix. And so that's the kind of workflow that we really want to enable, right? Where you can kind of bring these disparate tools and tie them together. This was announced in late 2018 by, and this is David Kalschmidt on KubeCon NA. And what do we mean when we say Prometheus but for logs? Right? Well, we definitely wanted to focus on the developer workflows, the debugging workflows that I mentioned, be able to pivot between metrics and logs. But we also want to make this very easy to scale, comparatively and operate, and use like really, really cheap storage, right? We want to compress your logs. Everyone's favorite, absolute garbage metric of success. I think we just kind of keep it in here as a joke. but I would be lying if I said I wasn't pretty proud that we just recently passed the 10K GitHub stars. We've definitely have seen a lot of momentum, especially recently, which has been very cool, and I feel very privileged to be a part of. So now jumping into our kind of data model, how this all works. We use two storage backends in Loki, right? So we don't actually store your data, with the exception of for a very short period of time. In Loki, we defer that to specialized storage backends, right? The first one is an index store, which basically stores the same Prometheus style labels that we use. And then the second is, an object store that stores what we call chunks, but are basically just compressed logs. And the index is tiny comparatively, because we're not indexing based on log contents, we're just indexing based on metadata. So, it's around 4 orders of magnitude, or 10,000 times smaller generally. And why do we do this? Right? So as I said, we want to index metadata, or labels, which is what we use, as opposed to the logs. You'd be able to store, potentially forever, your logs in object storage. And then we want to ultimately use this small index on labels to effectively route requests to the logs that you care about. And then we want to parallelize those operations. And then what that allows us to do is actually, this is my favorite part, right? Is it allows you to scale your read performance independently. So if you want to run a Loki cluster that is very, very fast to query, and you don't mind, paying for, it still will be relatively cheap a lot of the time, but commodity hardware to scale up your, what we call your read path, to scale up your queries, you can do that. And then if you have, use case where you don't care if it takes a little while to query this, you can run that much cheaper. But you can kind of choose and tune how you want to run this, which is, I think, one of the most fun parts. So now, what are logs in the context of Loki, right? We care about really 3 things. First one is your timestamp. And that's, we nanosecond precise, but we mainly use that for things like sorting and a bunch of kind of just parallelization benefits, in addition to, people generally care when their logs came from. And then your Prometheus style labels, and these are generally used to determine where they came from. I'm probably not going to jump too much into Prometheus labels here. And then the last bit is, your unindexed, the actual log content. And so we end up, as I said, kind of compressing these and flushing them very, very cheaply to object storage. So next thing I'm going to talk about are log streams, which are basically the set of log content associated with a unique label set. So in this case, right, we have our first stream, which is basically, your Nginx logs coming from one instance, and then your second stream is Nginx logs coming from a separate instance. And then these are what we call chunks, right? Just the log content that we ultimately compress. And then, so how do you actually query these things, right? Well, we maintain this really small index on top of the label structure. And so what we do is give you operations, which are basically, equality, inequality, regex matching, and regex, inverse matching, I guess. And that allows you to, do these sorts of things, right? Or, oh, hey, I want to match instances that look like this, that have this app label, right? And we'll take those matchers, run them against the index, and then that'll ultimately route you to the logs that you care about, right? These chunks, these compressed blocks of logs in object storage. And then we can take the second half here, which are basically, kind of like grep filters. And again, it's this kind of same set of operations. And then we can parallelize this pretty dramatically, which is where Loki gains a lot of its kind of performance benefits. So within a query, right, the first part, as I said, is your log selectors, we call it. And this does what I was just describing, where we take these, we route them to the index, and then ultimately fan out and parallelize based on things like filter expressions. One thing not mentioned here is we also support many of the same Prometheus functions. So you can actually extract metrics from your logs, and I'll show some of that later. Now, hold on. We do actually vend an agent for ingesting logs into Loki, and it's called Promtail. And the biggest benefit I think that we have is it uses the same service discovery kind of paradigm that Prometheus does, So if you're already using Prometheus, Loki tends to be an incredible fit, because you can generally drop your same set of configurations into Promtail that you use for Prometheus, and suddenly you have, you know, the logs that generate, or excuse me, your applications that generate metrics will also generate, you know, logs associated with the exact same label set, which allows you to pivot between them, which I'll get into in our demo. But don't worry if you don't want to use Promtail. You know, we have many other options. You know, they're kind of very, very common household names that we have plugins for. So before I jump into our demo, I wanted to mention that you can run Loki in a number of different ways, right? The first one is as a single binary, and this is basically equivalent to Prometheus, right? Where you run this kind of Prometheus monolith, right? And it monitors a, you know, fleet of instances, containers, application, what have you. You can do the same thing with Loki. And that's generally what you'll see people use when they're getting started, et cetera. You're also allowed to run in a microservices mode, which, you know, when you start caring about high availability, right? When you start caring about data durability, you know, and just handling large amounts of throughput, that's probably what you want to look at. And that's how we run Grafana Cloud hosted logs, actually. And then, you know, the last one, Loki as a service, right? Come pay my salary and we'll do it for you. Oh, I've got to jump into my demo, actually. So this is a sample application. I think we call these like waterfall panels, and they're basically like throughput on the left, kind of, you know, partitioned by like status codes, and then on the right, your latencies. So this would be an example, you know, 3-tiered web app with a load balancer, an application, and then a database layer. And if you look through, we can see that we're actually seeing these errors go all the way through to our database layer. So maybe, you know, I want to go in here and explore, which will send me to like kind of custom page where I can, if you're familiar with Grafana, you know, kind of massage queries as you wish. So now we go down and say, okay, and obviously I already know what to do because it's my demo, but you'll find that, oh, hey, we have elevated error rates, right? So let's pull out one of these layers, and we see we have, you know, all these 500s, right, which are spiking. Well, so again, I mentioned Promtail uses the same service discovery as Prometheus. So now we're going to switch just data sources, and it's going to propagate these same labels to Loki. And suddenly these are the logs generated by those applications, right? And then, so, all right, maybe we want to filter out, you know, some of this garbage, right? So maybe we don't want debug logs, right? And then suddenly, okay, this makes sense. I'm still getting a lot of, you know, kind of some of this is noise, but if you see, we have a bunch of, you know, too many connections, right? Lock timeout. So it looks like, you know, so what if instead, you know, we filter by error as well, right? So we've got these, you know, lock timeout, too many connections. It looks like we're basically, there's not a large enough pool to acquire the locks for our queries, which is ultimately causing our problems. And then, so I mentioned earlier that we can also do some like metric extraction as well. So I'm just going to pull up some queries that I already ran recently as an example. But here's actually, you know, kind of summing, pulling together by log level, you know, so the rate of basically logs generated partitioned by log levels for at this time range for, you know, this set of labels. But, you know, we can also do things like, as we looked at earlier, do regex matching, right? So if we don't want to look at just our database, we can get other things, which is pretty cool. So this would be an example that doesn't have, there's no log level associated with whatever this log is coming from. But this is kind of an example of how you can, of how the debugging workflow will go. So now let's jump back into presentation before I run out of time. I definitely need my notes, but you don't need to see them. So next, we're going to jump into some of the internals now that I've kind of given a description of the problems Loki wants to solve and kind of how we do that from a bird's eye view. So it will be a kind of microservice mode oriented approach, right? So this is kind of generally how we run things. And so maybe you have Promtail speaking to a load balancer, my pointer. Then we have a component called a distributor, which is basically responsible for replicating and what we call sharding data into another component, which is called our ingester, which is probably the most important subcomponent that we have in Loki, which is ultimately responsible for batching together writes and sending them into your long-term storage. And then we also can have components just for querying, right? So the query will talk to your ingesters for recent data, and then we'll talk to your long-term storage for older data as well. And so how do we actually store these things? We talked about storing compressed, what we call chunks, right? Which are these logs generated from your application, but what do they actually look like? So they're this set of labels, right? These log streams, and then they're timestamps, right? Basically the first log entry and the last log entry. So we can basically read the index and know which chunks we care about and partition that also by time. And then within each chunk, we keep all of the log entries sorted, right? Which should be not too boring to many of us. And that gives us a lot of parallelization benefits. Now you can choose, we kind of bring your own storage layer, I guess. We have a bunch of different supported backends for both chunks and the index layer. From your common, cloud vendor solutions, you can run your own file systems as well, that sort of thing. And then we do this for the index too. Now, this is, again, a kind of bird's eye view of what our index looks like, but it's basically stores these, kind of labels, and then there's other dimensions that we also have to do with a bunch of these sort of label matching queries as well, which are not included here, but that matches into chunks specifically, right, which include both the beginning and end timestamps. And so when a query is actually executed, we kind of go through finding which chunks we care about, and then parallelizing the operations, the filters, et cetera, on those chunks. And then if you're doing things like metric queries, right, we then will reaggregate them at a higher level. And again, bring your own storage for the index as well. And so you run, this is kind of our default BoltDB. It's an embedded database that we run. If you're running like BoltDB plus file system, which would be like kind of the Prometheus equivalent, of your single binary deployment, but you can also run with much more scalable solutions, right, that have better durability concerns, et cetera. So jumping back into our architecture doc, right, now we have, you can see that we both have an index and a chunk store that we use. And one of the things that, depending on how my time is looking, I want to talk about is how do we actually make sure that we don't lose any of your logs, right? So we use a concept called sharding, right? Where basically we take your incoming label sets, we hash them, and then that allows us to point to a particular ingester, right? And so that allows us to kind of fairly distribute load across your pool of ingesters and makes that layer horizontally scalable. Now, we run into some problems because if you actually have an ingester that dies, suddenly you lose all this data, right? So how do we handle that? Well, the very simple answer is we replicate it, right? Up to a configurable replication factor. So you can actually send your data to a number of distinct ingesters to make sure that you have you have durability up to a certain number of ingester failures. So this is all built on top of what we call the ring, which is a submodule or subcomponent in Loki, which is basically the combination of replication and sharding. It's a consistent hash ring, which is distributed across these ingesters. And I'm actually probably going to skip these slides in favor of some of the time concerns, but feel free to ask questions or come find me on Slack or whatever later and we can talk about it. So I want to get to the fun stuff. I guess it's all fun. But what I really want to talk about is the read path here, right? This is kind of the heart of the talk, and now that you understand how the index and the chunk stores work, how do we actually make Loki query things fast? So we have a component called the query front end, which is actually responsible for sitting in front of our queryers. And it does a couple things that I'm not going to mention in this talk, but I will focus on a few of the really important aspects that it does. So the first one is it's a scheduler effectively. So it sits in front of this bank of queryers, and it does some workload-based scheduling as opposed to round-robin scheduling. And ultimately, queryers end up pulling these jobs or these queries from the front end, and then executing and then sending them back.
Hey, Owen, sorry to drop in. Someone raised their hand. I think there's a question for.
Sure.
Sorry, I've not dealt with raised hands before, so I'm just looking to see if there's any feedback.
Yeah, it's new to me too. I will definitely get to the questions. I'd love to do it at the end.
Yep.
It's all right.
Cool. I just wasn't sure if it was something like a answer it now kind of thing. So yeah.
Sure.
Continue.
So the next thing that we do is we actually parallelize them, and I've hinted at this a few times throughout the talk, right? So one of the ways that we can parallelize is by time, right? So let's say you have a 24-hour query, right? That's looking for Nginx logs, and we are particularly looking for errors, but we don't care about errors fetching favicons, right? So what we can do is we can split them into 24 or 1-hour queries, right, and run those all in parallel. And then so the front end will build a job and queue them up, and then the subqueries will be run by these queries and then merged in parallel. Now, probably my favorite part, but I'm definitely biased because I worked on this, is a concept we call sharding. And it's built upon the sharding that we mentioned earlier, but with a slightly different flavor. But this is, it's a kind of the marketing material. This is a benchmark that we ran internally. Previously, we were kind of topping out at around 10 gigabytes per second on this cluster, and then we were able to turn on some of these new sharding optimizations and ultimately increase it by about 4x. And we actually didn't have instrumentation configured to high enough to allow us to actually measure this for a while. Yeah, here's Cyril, my buddy, saying it's about 20 seconds to go through a terabyte. So what is sharding? It's an index level thing that we do where we hash your labels, modulate into a shard factor, which is by default 16, but for this example, we'll use 2. So, for this first set of labels, this first log stream, maybe we'll go to the first shard, the second one, we'll go to the second shard, and then the third one will go back to the first. And it allows us to do other sorts of parallelization optimizations, right? So if you want a simple filter query here, that could also be kind of mapped into, parallel queries based on its own shard, right? So filter, all the series or all the log streams for one shard, combine them with all the series for the second shard, et cetera, all the way down. But that's kind of just the tip of the iceberg. There's a bunch of other things that we can actually do on top of this. And remember, this gives us just another dimension by which to parallelize. So you can still combine this with splitting by time. So we've definitely seen queries that come in, where you'll have one query and then, we'll ultimately send out, 1,000 or more subqueries, these tiny little units of work, and then, re-aggregate them. But so this is probably my favorite part, which is, can we use the sharding concept to find equivalent queries, which are more parallelizable? So this is the kind of sum rate query, which I hinted at earlier, which would ultimately extract a metric. But what it does is it says, I want, the rate of log lines that, have the ID equals 1, 2, 3 filter and are, match the foobar labels, right? And then I want to sum them across, all of my individual log streams. So what does that look like? Well, if you think about it, this could actually be a sum of sums, right? So we could take this initial sum right here and then map that into a sum of another sum that we execute on a downstream layer. So this is the same query, just appropriated for, one of the shards each. And so then they come down here. So we end up running these, which is the same query again, but just run on a single shard, and then the second shard down here, and then we sum them again. And so this is really just the tip of the iceberg. This is an example, and is kind of an area of development in Loki and Cortex, which we're really interested in right now. This sort of stuff has been happening in database development for a very long time. So it's certainly not novel, but it's very exciting for us and has given us some pretty, I guess, tremendous parallelization benefits. And So Cyril and I, Cyril is actually currently in Montreal and is the one that referred me here to give this talk, are the ones that I guess do a lot of work on the Loki read path. And we have been kind of, we like to think that we have a pretty good pace for improvements, but there's definitely an area of active development here. And we're very excited to kind of continue this. And that's the end of my talk.
Awesome.
So now I'm going to jump into some of these questions that we have.
Thanks, Owen. Fantastic, great presentation. And, you know, I hope this is just the beginning of the series from Grafana team. And as you mentioned, Cyril is from Montreal. He's about to become a father, so he asked you to present this wonderful presentation. So yeah, we're looking forward for Grafana to do the more events with us. And I think Grafana is a very popular cloud native project, which is not part of CNCF, but it's a very popular project that a lot of DevOps engineers are using, and and Grafana Loki would be an interesting addition to the to all this interesting space. So yeah, let's go with some questions, and then we're gonna start our trivia questions. So please, thank you everyone who's still with us, sticking around. I already started celebrating Kubernetes birthday party. I'm having some beer. I hope you guys too. If you let it work. So yeah, so let's see what we have. So Julian, one of our ex-speaker, and
yeah, he has a great question actually.
Loki, do you need to be careful about cardinality like with Prometheus? Would you include a path hello label in it?
This is a great question. You definitely need to be worried about cardinality because that's effectively our index layer, right? And so since Loki gains a lot of its benefits from parallelization, a lot of times trying to be overly aggressive in choosing how you index actually ends up hurting you in the long run, which is kind of counterintuitive, but it's definitely something that we've seen via instrumenting Loki. So would you include a path equals hello label? No, probably not. This is there's a great blog post by Ed Welch, who is the Loki project lead, on how to design good labels. But in general, yes, it's kind of the same, same issue that you have in Prometheus. Then,
fantastic. Can Loki dedupe identical logs from multiple agents? Questions from CS. And does Loki support external object stores, e.g. S3?
Yeah, it does. So yes, let's go with the first one and the second. So can Loki dedupe identical logs from multiple agents? So generally, yes, we can dedupe logs, but if you have identical logs from multiple agents, that might be a configuration kind of mishap, because we generally like to say that log streams are kind of analogous to files. So you probably wouldn't have multiple agents sending the same file to Loki. That makes sense, right? You'd have one agent, and maybe on each machine, right? Or if you're running in Kubernetes, right, running as a daemon set. So that likely would not happen. That is, you can definitely get more complex with that, but there's a little expertise required if you want to be like trying to outsmart Loki on how you actually organize your labels. And then does Loki support external object stores like S3? Yeah, yes, it definitely does. There's some docs which I would like to think are good because I wrote them last week before we had a separate webinar specifically on like configuration. I ran the storage section for that. And those have just now been added to the Grafana site, and then are obviously also in the Grafana Loki repo. But you have like cloud offerings like S3 or GCS, right? You can run local file system. We do have, just one came in, Azure Storage. We are actually running an Azure Storage cluster with it. I'm not sure if it's made its way into documentation yet, but yes. And then let's see, we have another question. If you don't mind, Archie, I'll just read these off.
Sure. Edith asking about the numbers shown on the last slide in the Loki presentation. Can you describe the scale of that cluster? How much resources was required to achieve that kind of performance?
This one? So one of the things I talked about earlier is how you can kind of scale the read path and write path independently. I think this used this used up to 75 CPU. Yeah, Cyril's saying right there at the bottom. And that was probably most, from what I remember, most of the available CPU on that cluster.
Right. Owen, do you mind if you can answer the questions that are still there? I would like to kind of finalize the, the event, and we have the trivia. So thanks again to all our speakers, Owen, Steve, Chris, amazing job. If you want to get back online here, thank you. Nice to see everyone here. I will share my screen again, and we're going to start the trivia going. So hopefully you can see the screen. Can you see the screen, guys?
Definitely.
Yeah.
All right. So first of all, the first way to win the prize today is to fill up the survey. So all the winners will be part of the draw. So I'll just ask you to take your cell phone and barcode, it's on the screen. So just scan it. And this is just provide us feedback about, the speakers and what we can do better. It's helpful, but we decided to also make a quick draw. So fill it up. And for the next, for the last part, we're going to be doing Kubernetes trivia. You would also need a phone. So you need to have your laptop, showing the screen, and you need to have a cell phone with the browser. That's all you need. So I'll take you. Yeah, thanks, Steve, to taking it out. So I'll just give you a few seconds to take a picture of this event survey. At the end, you'll get a prize. For the people who would do the survey, we're gonna make a draw, and there will be one winner. We'll get some swag. And then for Kubernetes trivia, you need to go to open your browser and go to kahoot.it, and we'll have the first winner. The winner will get a Kubernetes hoodie, and the other second and the third place will get a nice prize as well, probably t-shirt from the CNCF store. So definitely worth to try it, and I hope it's going to be a good experience just for everybody here. So basically you need to get into the kahoot.it and put the pin. So if you have any questions, something is not working, let me know. So right now I see CS. There's people joining. Steve, I hope you don't know all the questions already. But yeah, come on guys, keep joining. We're gonna start maybe in a few seconds. And I'll just leave my screen here with the post survey as well. You can, please go ahead and fill it up. We'll make some prizes as well there. So just survey. All right. Yeah, all right. So we have 20 players already. I don't know if anybody wants to join more, because we have about 50 participants today. So come on, guys. 22, 23. All right, I guess the rest 25 people don't want to have a hoodie, so it's okay. All right. Okay, so 10 more seconds. So quick tip, please keep your laptop on because you'll see the question on the screen, and using your phone browser, you can answer the question. If you just have a, one screen, is going to be a little bit difficult because you have to switch on and off. So I would really recommend to have a phone with the browser, and you put Kahoot.it, and then you put your, you leave your laptop on just to see the questions on the screen.
It's kind of like You Don't Know Jack, a Quiplash, or those kinds of games, if anyone's played those.
Yeah. All right, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're starting. All right, can you hear the sound? All right, the first question. What is not part of the Kubernetes control plane? That should be fairly easy for you guys. You all experts of Kubernetes today. Okay, we're waiting. All right, kubelet is not part of control plane, and scheduler, API server, and controller manager is the main pieces. So majority of people know their stuff. So let's see who is winner now. Steven, of course, who would guess? And we have Ben and Hisham. Okay, so that was the easiest question, guys. Buckle up, as things gonna get more complicated now. This field and service can be used to make sure that connections from a particular client are passed to the same pod. So it's a field and the service manifest that you can specify, and it will make sure that the connection will go to the same pod. All right, look at you guys. A lot of people get a good answer. Steve is still first, Andrew second, and Hisham following. Question number 3, the number of minor version nodes may lag the master version. All right, come on, guys. Wow, great. So 14. I actually made it wrong. I thought it's 3 actually, and the correct answer was 2. Good job, guys. Steve is still on top. It's gonna be sad if you're gonna take the hoodie from Canada.
That's gonna be an expensive import tax.
All right. Multi-select, so you can select two correct answers. This deployment rolling upgrade strategy field specifies the max. I think this is actually incorrect here. You need to select one. I think it was a small mistake here. Yeah, the max surge was correct, and the majority of people was correct too. All right, so Steve, you're still on top, man. Going ahead, and Udit is second now. All right, a command used for troubleshooting purposes that creates a temporary container in a running pod. So if you like to troubleshoot Kubernetes, you should know that very well. All right. Yeah, so there are some people who are thinking it's kube attach. Kubectl attach is good to jump on for troubleshooting, but it doesn't create a temporary container per se. So the correct answer is kubectl debug. So quick tip here, if you want to get more points, you need to answer as soon as possible. If you wait till the last moment, your numbers will be lower. So the person who is the fastest to click the answer is going to get more points. So try to make sure you do it faster. All right, 6 more questions to go. It's a double question. So a tool for running local Kubernetes cluster using Docker container nodes. I think we had the answer already during the meetup today. There was some people mentioning it.
I like the little logo that's being built there. It's a nice touch.
All right, so this is kind. Good job, guys. So we used to be another project called Docker and Docker Deaned, and I think now it's official from Kubernetes community. It's called Kind. So it's a great project to use for testing and troubleshooting. Okay, multi-select. So you have to select 2 options. What are 2 CNCF host GitOps projects? That one should be easy after this meetup. You guys probably all experts in GitOps today. All right. Good job, guys. So majority is correct. So we have Steve, you're still on top, man. Udit and Chris coming right after. What is the CNCF project level is Argo CD at? So that one should be fairly straightforward, but maybe some people not aware yet. So as you know, CNCF has graduated incubating and sandbox projects. So yeah, the majority of people are correct. Number 12, incubating. All right, the next question is, what is the name of the Fluxity project used to manage Helm? I think actually, Chris, you should be knowing because you were talking about this today again. I hope the others can make it as well. And the answer actually you can see now on the screen as well. Wow, good job, guys. I think most of the people were listening the talk, so most of the people are correct for the answers. And we're going to next one, number 10. A Kubernetes-based CI/CD system with this logo. And the logo is like this. Uh-oh, that was seems to be apparently was very difficult to answer. So it's a project called Pro, used for testing. Yeah, Chris, you want to say something?
Oh, it's just kind of there's a typo which might have thrown people off.
Oh, really? Okay, that's probably my bad. But yeah, it's used for the internal Kubernetes testing, right? A lot of times for the internal CI/CD of Kubernetes. All right, so question number 11, a Kubernetes-based CI/CD system with the following logo. All right, some people are thinking, should it be Kubernetes or something else?
Kubernetes was the best Kubernetes release.
I knew that it will, people will mess up here, but like Kubernetes is one of the Kubernetes releases. It's not the CI/CD system, but it was a CI project tacked on here. So
that would have been a good question, though. What release was Kubernetes?
Yeah. All right. So last question, guys. 2 points, 2x points. What is the name of a new CNCF project that lets you deploy cloud resources using CRDs? Okay, I don't need to even tell what is the answer because you can pretty much read it now on the screen. All right, good job. So time to see the finalists. Today, GM is got a 3rd place. He's gonna get a t-shirt. Chris is a 2nd, and Steve, I guess, who else? Steve, congrats. I'm not sure now. I need to check the rules if we allow.
4th and 5th should be bumped up.
Yeah, if we, is that Chris, is you?
Yeah.
Oh, you cannot do this, man. So, okay. So we'll keep the price for Steve, but we're also gonna look for our users, like, so the GM, and I think we'll check. The GM will get a prize, and I think Puerco. So I will make sure that the people who are from the users will get the prizes. Our speakers are getting, prizes as well. So, you guys go to get your prizes anyways. So I need to make sure. Yeah. So the GM is the winner pretty much. So we'll send the GM the hoodie, and Chris and Steve, they are speakers. So they will get their own prizes anyways. So congrats to GM. Good job.
Porco and
yeah,
R.
Puerco and R. Please send me the message who you are, like what is your email, or if you're in the Slack channel, let me know. We'll send you the t-shirts, and then GM is gonna get the Kubernetes hoodie. Congratulations. All right, so I think that's it for today. We actually need to check the survey results. So let me just check quickly the survey. All right. So we got Kubernetes. Okay. We have 15 people who submitted. So I'm gonna quickly share the wheel. Okay. Can you guys see my screen again?
Yep, it's up now.
All right, so we have 15 people who submitted. I exclude myself from the list just to be fair. And we're gonna, turn the wheel of fame, see who is gonna get this prize. So for this, we'll get another t-shirt from the CNCF store. All right, so let's go. All right, Zilardo is the winner. Congrats, Zilardo. So that's it for today, I think. Thanks everybody who stick around. There was actually 2 hours meetup, first time we made it so far, and a lot of participants. So very excited about this meetup. And